Hello, and today we're going to look at the Troika Systems Anycam with Gravure QC. This is for the measurement and recording of gravure cylinder wear and cleanliness. First, let's start with the Anycam itself and a guided tour of what is contained. As you can see, the Anycam is sat on a test cylinder, so let's have a look at what's involved. The Anycam main body here, interchangeable lenses at this section here to allow for differing line screens, stable legs for mounting on the cylinder, an X-axis adjuster to locate particular elements, built-in lighting with automatic contrast setting to remove any glare or reflection from the chrome, and a battery pack to allow testing without the need for mains power support. So let's now go on to the software. So now you can see we've placed the camera onto the cylinder and are ready for doing some measurement. I have some controls here in the setup to allow me to zoom in or out of the image, to adjust the lighting if we wish to do something additionally for the material, and depending on our engraving, whether mechanical or electrical, chemical engraving, and to remove the reflections from the chrome, reflection balance system, and to remove the curvature from the cylinder to compensate for that. For security printers, we have the option of turning on or off the intaglio media support for intaglio engravings. We can then save those into a known value for future reference. So we're ready to scan. First of all, we may wish to use the 2D snap analysis. This is simply a 2D picture of the image and allows us to populate very quickly the 2D analysis. So opening, height, angle, wall and channel settings. There is no information regarding the stylus or depth and volume of measurement. It's purely for 2D analysis, but can be very important to understand the properties of the cylinder engraving. If I look at the 3D engrave mode, then we can click the scan, and this will initiate some scanning. First of all, automatically focusing for the top of the cylinder wall. This is within 1 micron and removes any error from the operator manually adjusting the focus. We then look at the lighting to adjust that correctly, and now we calculate the reflection balance system, and you will see how the lighting is automatically adjusted so it remove the reflection from the cylinder. Now we start our scanning cycle, which takes typically 60 seconds to complete. It is taking a snap picture through the cell from the very top of the cell wall to the bottom of the cell itself. And this is automatic. The user just needs to have a small amount of patience while this information is gathered. See there, we're nicely through the bottom of the cell, and automatically the camera will calculate the information. This is processed on the host computer, and automatically we get the volume and the depth. But of course we want to populate the 2D analysis data, so automatically we're left in the 2D analysis window. So I can click anywhere in the complete cells. If it's an incomplete cell, it will not calculate the information. So I have all my information there, and now you can see I have the opening, the height, the angle, the wall and the channel, and for wall data the minimum and maximum values of that, because there are different thicknesses of wall on the same engraving, as we can see here. By clicking Set, that information is then completed into the software. So now we have our opening, height, wall and channel, as well as our volumetric screen angle and depth. Here I can enter some information, and in particular the cylinder ID, which is a unique reference and allows us to monitor the history of that. I can also add some comments. In case there's something particular regarding that. From here I can generate a preview of the printed information sheet, and you can see here that I'm able to generate the report with the operator, cylinder ID, date and time, customer, all of the cylinder specific information, a picture of the cylinder and the position of the measurement. I can of course take multiple measurements across the width of the cylinder to allow me to see if there is uneven wear across the web. My comments are marked here, and if I need to publish this as a written report and sign, this can be completed. So now I have my view of my 3D model. So what I might want to do is look at the cell profiling. And first of all, let's look at how the cell is performing in terms of its engraving. So if I take a line across here, now I can see how that engraving is looking. You can see here, this is the curve of the engraving. I can also do this in multiple directions, and more importantly across the channel to make sure that the channel actually exists and is complete. And you can see this looks a pretty good engraving. So having looked at that, I maybe want to calculate the stylus angle that was used to create the engraving. Simply measure across the width of the engraving, dimension cell, draw the left gradient and the right gradient, and then the cell opening. So from this point here to this point here. And it shows me that the stylus that was used to create this engraving was in fact 121 degrees. If I enter that information into here, 1, 2, 1, 0, then when I look at the profile of the analysis, you can see with that stylus we should have a depth of 31 microns, and in fact we've actually got a measured depth of 30 microns. So that looks like we've got a very good engraving for that. So that is where we are. We know we've got a good cylinder. But what of the cylinders which are not so good? So let's remove these values across here. Of course we can delete all, but let's check these. And what I want to show you is how we can interpret the cleanliness of the cylinder. So that if I right click in the image, I have a small dialog and a fade control. At the moment we're set on 0, and this is looking at the quality of the engraving on the cell wall tops. So if we were suffering from score marks or something of that caused by aggressive blade or ink, then we can check the condition of the cylinder. If I fade this to the 50% level, I can see all of my 150 scans, so I can now see how the engraving has been made and how it's performing. And that looks not too bad. Lastly, I can draw this right down to the bottom of the engraving, and I can see from the very deepest sections of the engraving through the walls of the cells and finally at the top of the cell walls. This allows me to show the image in 3D. So now I can see the condition of my cylinder and investigate any particular issues that I may have. And of course, being able to zoom in to see the detail of the engraving. Having completed our measurement, what I'd like to do now is export this to our database management or an external software program. But in this case, it's going to be to our database management.